Welcome to the ThinkyHearts YouTube channel. ThinkyHearts, in collaboration with the Nigerian Institution of Energy, Electrical and Electronics Engineering, NI4E, is pleased to present this recorded webinar, recorded on Thursday, 23rd July 2026. In this session, we explored one of the most promising frontiers in the global energy transition, Nigeria's green hydrogen pathway, a strategic framework for climate neutrality and energy security. Leading this discussion is Engineer Kamilu Lawal, a registered engineer with a PhD and a renewable energy engineer, researcher, and lecturer at Abubakar, Tafawa, Balewa University, Bauchi. His work focuses on renewable energy systems, smart grids, power-to-X technologies, and green hydrogen, placing him at the forefront of research and innovation supporting the transition to cleaner and more sustainable energy systems. He also serves as chairman of the Bauchi branch of the Nigerian Institution of Energy, Electrical and Electronics Engineering, NI4E, where he continues to champion professional excellence, engineering innovation, and sustainable energy development. In this presentation, Dr. Lawal examines the opportunities, challenges, and strategic decisions involved in developing Nigeria's green hydrogen economy, and what this emerging sector could mean for energy security, industrial growth, investment, and climate action. Whether you are an engineer, policymaker, researcher, entrepreneur, student, or simply interested in the future of sustainable energy, we believe you will find this discussion both insightful and inspiring. If you enjoyed this webinar, please like this video, subscribe to the ThinkyHearts YouTube channel, and share it with others who may benefit. Now, let's begin.
So quickly, what is hydrogen? I think from our secondary days, we know what hydrogen is all about. It's one of the most abundant chemical elements in the universe. It's always bound up in water as H2O. It's an energy carrier, and this means it must be produced using another energy input. It has a very high energy density by weight, with low density by volume, which is a stress for engineers, as we are going to find a way to make sure it's well transported. When using fuel, it's like a byproduct of water, like I mentioned earlier, and the chemical formula is always H2O. What are hydrogen production color codes? Like we have in electrical engineering with color codes of resistors, hydrogen also have what we call color codes. And I'm going to start with gray hydrogen. The production shows the color actually. So gray hydrogen is produced via natural gas through steam methane reforming. It emits a lot of carbon dioxide, and there's no carbon capture technology when you use gray hydrogen, and it's the most popular form of hydrogen production today. Then we have black or brown hydrogen. The technologies are same as gray hydrogen. Coal is being used instead of natural gas, and is the most environmental damaging. We also have blue hydrogen, same procedure as gray hydrogen, but it has a carbon capture, utilization, and storage method technology, and they can be stored underground or use them and later used in industrial processes. We have pink or red hydrogen, which is produced from a nuclear energy, and there is no emission of green gas. Then we have turquoise hydrogen, uses methane pyrolysis to produce hydrogen and solid carbon. It is yet to be proven at large scale. There's also yellow hydrogen, and there is white hydrogen, which is new, and is found in underground deposits. It's produced by fracking, and there's no strategy to exploit this presently. So finally, we have the last one, which is green hydrogen, which is why we are here today. And it's formed from a process that is called power to X, as a process in which electrical energy is being converted into other form of products. So hydrogen is one of the products. When hydrogen combined with other chemical, it can form methanol, it can form urea, it can form all other products. And that is why the X come at the end of the day. It can be so many products. That's what is significant of green hydrogen. First and foremost, it is clean and sustainable because it is being produced from renewable energy resources. It is storable. It is a versatile gas which can be used for power generation, can be used in agriculture, in transportation, and so on and so forth. And also, it is very, very transportable. So let's look at the global context of hydrogen and let's see what is happening globally when we talk about green hydrogen. I'm going to be using this graph to make my points. And basically, 5 bodies have projected the use of hydrogen by 2050. International Energy Agency, there is Hydrogen Council, there is IRENA, which is International Renewable Energy Agency, there is the Energy Transition Commission, and finally, there's Bloomberg Energy Finance. I'm going to be looking at industry, transport, power, and building it, and final energy. From this graph, BNF Green Climate proposes that by 2050, the final energy is going to be like about 22%. The most important application is industry, which is where we really need to focus on with regards to green hydrogen. Hydrogen Council also have the same proposal. Their final energy is coming to about 17%. And IRENA, which is International Renewable Energy Agency, also proposes that by 2050, the final energy is going to be in the neighborhood of 14%. This leads to many national hydrogen strategies by companies, especially we look at Germany, Japan, and Australia. These countries are really putting up some efforts to ensure that they really contribute to the global context of green hydrogen. It's also good for the decarbonization of the hard-to-abate sectors. Green hydrogen is seen as one viable solution for sectors that are not easily to electrify, especially the aviation and shipping, also the heavy industry. And green hydrogen is becoming a tradable global commodity, and countries are really pledging a lot of money to ensure that they are part of the hydrogen in the future. So the European Union also projected by 2030 there's going to be 10 million tons of hydrogen produced by year, and Nigeria has a share of about 17%, which is the third largest in the continent. Also, developing countries are also coming up with different strategies, especially with Namibia, Morocco, and Egypt, South Africa, Mauritania, and Kenya. They already form an alliance, and Nigeria is now left behind somehow. But we are going to look at some of this information later. Then Nigeria has already has a real hydrogen demand, in which most of them are for agricultural applications with reference to ammonia, but they are not yet we have not yet formed an alliance for export positioning. Now let's talk about the Nigeria energy landscape, because it's very, very important to understand the landscape with regards to green hydrogen. So we have what we call the Power Holding Company of Nigeria with our energy landscape. This constitutes 25 generating stations. We have 1 transmission station. Yes. Then we have 11 distribution companies. They are being monitored and controlled by the National Electricity Regulatory Commission and the Federal Ministry of Power. So this is the situation of Nigeria presently. I don't think that we have a resource problem with what we have. We have about 13,000 plus megawatts in solar generation, 31% plant availability as at April 2026. We have 61.2 national electricity access rate, and we have about 26% rural electricity access. Our system is heavily fossilized with gas-fired power plants, which is about 80%, hydropower plants about 20% plus, and the contribution of solar photovoltaic is about 0.1%. So this gives an opportunity for off-grid system, which is the fastest growing in the Nigerian context, with over 200 plus mini-grid installed in 2025. Over 900 plus is still in development stage, and the target is about 1,350 different installations. These are renewable energy potential. We have an average solar radiation of about 5.5 kilowatts per meter square per year, which is very, very high. We have over 200,000 megawatts of solar capacity. Our wind speed is not the best, but in the coastal region, we can boast of about 4 to 6 meters per second of wind speed. we have a lot of potential with regards to hydro energy also, with existing dams, and there are still untapped small-scale hydrogen potential. The government is trying to target 277 gigawatts by 2060, and renewable energy has a role to play with regards to other private investors. So what is green hydrogen again? Like I mentioned earlier, it is the production of hydrogen through renewable energy using electrolysis of water. The electrolysis process is straightforward, which is the splitting of water molecules into hydrogen and oxygen. And at the end, hydrogen is being produced. Here, there is zero carbon emission during production and use, and the applications varies from transportation to industrial applications, to power generation, and to energy storage. Renewable energy source can wind, solar, give us electricity. We need some form of water, which will be splitted using electrolysis into hydrogen, which can now be stored. This is some chemical equations that is being used for the production. So without electrolysis will not happen. So we are looking at electrolyzer, and one of them is what we call proton exchange membrane electrolyzer. This is the diagram for the proton exchange. We have the water inlet, the water and oxygen outlet, the power source, and also we have electrolyzers, which is alkaline in nature, and another type called solid oxide electrolyzers. The hydrogen can also be stored. These are different types of storage. We have compressed hydrogen gas, CHG. We can have liquid hydrogen storage. We can have metal hydride storage. They can also be transported using pipelines. Also, we have what we call hydrogen carriers with chemical compounds like ammonia and liquid organic carriers used for transportation of hydrogen more safely. Fuel cell also converts hydrogen into electricity, and this is what is being used in some car manufacturing companies. Hydrogen can be combustible as a fuel for internal combustion in engines, and hydrogen can also be blended with other gases to get other existing products. So this is the value chain of hydrogen, from power generation to conversion and to the end user. This diagram is showing the versatility of the gas. If you look at the right side, we can look at the end use, which is hydrogen to fuel, can be hydrogen to fuel gas, can be hydrogen to fuel liquid, which is being used in the transportation sector. In the residential and commercial sector, there's hydrogen to power, there's hydrogen to heat, and in the industry, there's hydrogen to chemicals. These are all the value chains of hydrogen. So why is green hydrogen, where green hydrogen fits in Nigerian specific circumstances? Number one, we have a strong solar resources. So why does green hydrogen fit Nigerian specific circumstances? And number one, we have to look at our abundance renewable energy potential, which shows the fact that we have strong solar resource. The high irradiance across the country gives consistent daytime generation for electrolysis. Of course, there's also water availability. There is storage potential also. And because of the fact that we have about 39% unmet electricity demand, is also give us room in which green hydrogen can fit into Nigerian circumstances. Of course, we can also make use of our existing infrastructure for transportation. And if you look at the Nigerian map, this is why green hydrogen fits Nigeria. So what are the pathways to green hydrogen future? We are going to be looking at 3 or 4, which can be energy security. We are going to be looking at industrial decarbonization, and also the export climate. Near time, the most important part is the energy security, which we are going to be looking into now. So energy security in Nigeria's green hydrogen pathway. The most important aspect is the fact that it helps us to diversify Nigeria's energy mix by reducing the mix. About 80% of our power is from natural gas. With the introduction of green hydrogen, it gives them an opportunity to diversify our energy mix. This leads to improving energy independence. And because of the fact that hydrogen can be stored, it gives us an opportunity for long storage. It promotes also decentralized energy, and it strengthens grid stability because there are now hydrogen-based generators that can work with green hydrogen. It also supports the integration of variable renewable energy. So this gives us the opportunity to address the issue of intermittency challenges which are associated with solar and wind power. So industrial decarbonization in Nigeria's green hydrogen pathway. This replaces fossil fuel in energy-intensive industry. It substitutes gray hydrogen, which is the most popular hydrogen presently. It enables low carbon steel production. It supports low carbon cement production. It can facilitate carbon capture, utilization, and storage. We can electrify the hard-to-abate industry using green hydrogen, especially with the industrial application, and it gives opportunity to reduce industrial dependence on natural gas. It promotes cleaner manufacturing by lowering carbon intensity across industrial value chains, and the petrochemical industry can also be decarbonized, which gives opportunity for sustainability of the Nigeria as energy sector. Exports in Nigeria's green hydrogen pathway. This leverages Nigeria's abundant natural resources with regards to solar and wind and natural gas infrastructure, because Nigeria have a strategic location along the coastal region. So it gives us an opportunity to export ammonia. It also gives us a position as a regional leader when it comes to green hydrogen production. This can diversify our earnings with regards to foreign exchange beyond crude oil and natural gas. So this also reduces our vulnerability to volatility of the fossil fuel markets. This will create a new foreign exchange revenue stream for Nigeria. It will support the export of ammonia, which has a good application in fertilizer manufacturing. It can also attract foreign direct investment into the country. So the last aspect is climate neutrality. A carbon footprint means the total greenhouse gas emissions caused directly or indirectly by an activity or a product. And net zero emissions means achieving a balance between greenhouse gas emissions produced and emission removed. It's like +1 and -1. When you had an emission, you have to develop a mechanism to remove that emission. So these are some of the terms that we need to understand when we talk about climate neutrality. So climate neutrality as green hydrogen pathway, it gives us a long-term pathway to achieving net zero greenhouse gas emissions across the entire energy system. It also replaces the fossil fuel with renewable hydrogen in electricity generation, in transportation, in industry, and in heating application. It supports the production of carbon neutral fuels, which include green ammonia, methanol, synthetic aviation, and marine fuels. Climate neutrality also improves environmental quality by reducing air pollutants and greenhouse gas emission from fossil fuel combustions. This promotes sustainable economic growth and strengthens resilience to future carbon regulations and international climate policy. This also positions Nigeria as a leader in Africa's transition to low carbon and climate and neutral economy. So what are the challenges to green hydrogen adoption in Nigeria? The first and foremost is the high initial investment costs. Electrolyzer, fuel cells, and storage system required significant investment. There is infrastructure gap or limitation. There is also policy and regulatory barriers. We want clear policies. We want safety standards and incentives to promote green hydrogen production. We also want supportive regulatory framework, which will encourage a lot of private sector investments. Technology readiness is also a challenge with the current stage of development of hydrogen technology and their scalability. Limited skilled workforce with regards to hydrogen and fuel cell technology. Then public awareness and acceptance is also an issue which we need to look at. Because it's not just enough to come with a new technology, people need to be carried along and they needed to be aware of all the benefits of the green hydrogen. What are the opportunities of green hydrogen adoption? Local content development. This will encourage the use of local expertise, materials, and labor in hydrogen projects. Green hydrogen production for domestic and export markets. the European Union and Asian market will have strong demand for green hydrogen, and we can become a regional supplier in this regard. Green hydrogen also can be used for fertilizer production, which gives the room for reduced import dependence and support food security. There's going to be job creation and industrial development, which will create new value chains of hydrogen, and employment in engineering operation and research opportunity with green hydrogen projects. So let's look at some case studies. Germany, they are leaders in green hydrogen technology with the Green Wilhelmsen project, which is 1 gigawatt electrolyzer capacity. That's the project for 2028. They are also investing about 140 million euros for the GET H2 nucleus project, which is about 300 megawatt capacity in 2027. South Africa is not less behind. They are looking at the Hydrogen South Africa initiative, and Saudi Arabia, they have the new project which produces green ammonia. The plan is to produce 650 tons of green hydrogen daily from solar and wind. What are the action plans for the engineers? We need to begin to find a way to be involved in green hydrogen. Awareness is important, and advocacy. We have to begin to promote green hydrogen among policymakers. We have to find a way into the House of Assemblies to begin to discuss all these potential of green hydrogen with regards to Nigeria, especially with the abundance of the renewable energy resources that we have. Then we have to form collaborations. Researchers and research institutions have to collaborate. We have to build capacity, which involves training professionals in the green hydrogen processes. This will lead to innovation, and we must look at Nigerian-specific solutions. In conclusion, green hydrogen presents a transformative opportunity for Nigeria's with regards to energy security and climate neutrality goals. There is also sector coupling, which gives opportunity for power and industrial and transportation applications. This will give room for sustainable development. So by leveraging renewable energy resources, Nigeria can produce green hydrogen, ammonia, methanol, and synthetic fuels to support economic diversification, create jobs, and new industries. This will strengthen Nigeria's global energy leadership. So what's the takeaway? Realistically, by 2050, we should target to produce 5 to 10 million tons of green hydrogen. This will be deployed via large-scale renewable energy projects with modern electrolyzer capacity, which supports hydrogen infrastructure. This production level will satisfy domestic demand while positioning Nigeria as a major exporter of green hydrogen and green ammonia in Africa. These are some of the references for this presentation, and I would like to take you through a tour of green hydrogen in 2024 that we attended in Europe. This is a green hydrogen facility, and from the diagram, look at the electrolyzer, and the upper tank is for the hydrogen, and which is being separated from the oxygen. These are some of the participants, and these are some of the group pictures. So the technology is in existence with availability of our renewable energy. I think we should also key into this technology. This system is powered by wind turbines, which is a renewable energy source. And one wind turbine produces almost high amount of power, so which makes them to be cascaded and be able to be used. The whole height of these turbines is about 100 meters high. And because of their strategic location, they harvested a lot of wind resources, which makes them to be easy to power the electrolyzer. So this is the storage of this hydrogen. And as I mentioned earlier, they are powered using wind turbines. Thank you very much for this opportunity. I will allow the moderator to now take control while we engage and interact. Thank you very much.
Thank you very much, sir, for that insightful and enlightening presentation. Please, a round of applause for our speaker today. Your presentation has really deepened our understanding of the opportunities, the challenges, and strategic consideration surrounding green hydrogen and its potential role in Nigeria's journey towards climate neutrality and energy security. Thank you once again, sir. We will now proceed to the Q&A session. Okay, Tasiu Wudil, please go ahead.
Thank you, Ma. And thank you, Dr. Keo, for this very insightful lecture.
Thank you very much, sir.
My question is like a comment still a question anyway. From your presentation, yes, we have green hydrogen, which in other parlance we call it clean hydrogen, and it means that it's dirty hydrogen, which uses fossil fuel to produce the hydrogen. From your own definition of the green hydrogen, is you use green energy to generate the green hydrogen. How green is the energy? Because breaking the water molecules is not an easy thing. It may need a lot of energy, the entropy to break the bonds. And I just want to know some cheapest ways of generating hydrogen. Let's say at home, if I want to generate hydrogen for my own use, maybe I want to use hydrogen cell. I want to produce hydrogen cell. Are there ways, clean ways, no green ways that at home I can use that may not have to use energy, a lot of energy? Thank you.
All right, thank you very much, sir. Yeah, I made mention earlier, hydrogen is not new itself in its entirety, but what makes this one green is because of the fact that it's being produced using renewable energy. So the electrolyzer that splits the water molecule uses a DC power source. And once your renewable energy sources can provide this DC power source, I think that is enough. So that is the standard technology that's being used. And now, with your question on the amount of energy used, there are now advanced electrolyzers that, with your design, they will not take much of the power required. And for your question that you can produce hydrogen at home, of course, there are some laboratory techniques that you can produce your hydrogen at home, which you can just use to inflate some balloons. We have done it at laboratory level here also. What we do, we just get this low-cost electrolyzer. We just split the water molecule into two. We just made some low DC power supply, and hydrogen is generated at the cathode and anode. My professors in chemical engineering are all here, and they are conscious of the fact that this hydrogen can also be laboratory produced. Thank you very much.
Thank you.
I hope I've answered
your question. I
didn't
know that I asked 3 questions. Thank you.
Okay, we have a question from Joytide Baker. He says that he sincerely appreciates the opportunity to listen to you this evening, Doctor. God bless. He is a postgraduate student studying environmental chemistry in Adamawa State. He wants to write his thesis related to renewable energy and the Green Hydrogen Initiative. Can he reach out to you for guidance on his thesis and future research and collaborations? And how does he go about that, please?
Thank you very much. We have submitted a lot of proposals with green hydrogen. Some of my professors online can bear me witness. We wrote a proposal on using solar to hydrogen technology for agricultural purpose. Urea is a form of fertilizer that can be used in agriculture. The chemical component uses hydrogen. We are working on this project for more than 2 years now. We submitted a proposal at state fund level. Well, I don't know why the proposal was not selected, but the issue is that there is a lot of research in green hydrogen technology. Either it's been selected by state fund or not, the research will not stop. Also, green hydrogen also finds application in hazardous, conflict-affected area because of the fact that it can be stored longer than normal battery. It's also find application in conflict-affected region. We are also looking at that also. You can reach out to the moderator and get my contact, or I can drop my contact for you so that we can take it up from there. Thank you very much.
Thank you very much, sir. Please, do we have any other questions? Okay, the Ayuba Adamu dropped something in the chat box, but it doesn't seem to be a question. He said solar PV plus alkaline electrolyzer, Limpopo, South Africa, approximately 2.12 USD per kg, standalone system. Alkaline electrolyzer is the cheaper tech. Please, can you clarify if this is a question? you'd like us to answer, Mr. Ayuba?
No, sorry, it's not a question. It's just extended in addition to what the Femi Lawal said.
Okay.
In South Africa, it's been prototyped and it's been identified that you can use as low as $2 to get a kilogram of green hydrogen from a facility in Limpopo, South Africa, where solar PV and alkaline electrolyzer was used. And I think that's about the cheapest so far by the little stories I heard sometimes back.
Yeah, thank you very much, Mr. Adamu. I think that price is very competitive.
Yes.
It's approximately about $3 per kilogram is the standard practice. And if you can get at 2.12, I think that is highly competitive.
You can check out. It's in South Africa. The facility is in South Africa, Limpopo, South Africa.
Yes, I agree with the assertion. I'm just confirming the fact that it is even it's way cheaper than the standard $3 per dollar. I'm confirming what you are saying.
Thank you, sir. Thank you.
You're welcome.
I am actually a student of Renewable Energy University of Abuja. You can't do anything renewable without touching a lot of things.
You're welcome, sir. I will be learning from you, sir.
No, we are all learning from each other. I am a student, or I'm not a full-scale researcher, just a student.
Thank you very much, Mr. Adam.
Thank you, sir. Yes, sir.
Okay, we have a hand raised. M.A. Bauer has raised a hand.
Professor Bauer, please go ahead, sir. Okay, sir.
I actually want to say that you have selected a topic that is even a global issue, not even a localized African or Nigerian issue. Hydrogen, clean environment is the topical thing that's going on, and I'm happy you're able to carry out, like you are talking to primary school, at least to enlighten the audience on what is even the green what is hydrogen first before the green hydrogen and its own formation. I think this is a monthly issue, so that maybe we can be having it monthly or quarterly or some, so that we can carry out the enlightenment programs. Thank you very much.
We will continue with the series. We've been doing this for a while, and we just have to be consistent. We will try and make sure at least once in a month we come up with a topic for discussion by the grace of God and with your support. So we'll make sure it's regular. I don't want to say what we cannot keep up with, but we'll make sure now that it's now regular. We'll keep up. Thank you very much, sir.
Okay. In the absence of any further questions, we would like to bring this meeting to a close. We would like to say a big thank you to our distinguished presenter, Engineer Kamilu Lawal, for sharing his time, expertise, and valuable insights with us. You can also reach out to us via our website at ThinkyHearts.com. If you enjoyed today's session, you can subscribe to our YouTube channel. Some of our previous webinars include sessions on MEPS, minimum energy performance, among other topics related to renewable energy, sustainability, and climate action. You can also reach out to us via email at info.thinkyhearts@gmail.com. We encourage you to follow us, subscribe to our YouTube channel, and also stay connected for future webinars, research projects, and collaboration opportunities. If you are a student or a professional who would also like support in any area of research or a topic that is of interest to you, you can also reach out to us and we'll be more than happy to support. Once again, thank you to our speaker, our partners, every one of you for being part of today's webinar. It has been a pleasure and privilege to serve as your moderator. And on behalf of ThinkyHearts and NI4E, I wish you a wonderful evening. Thank you for joining us. Stay safe, and we look forward to welcoming you to our next ThinkyHearts webinar. God bless you all.
Thank you.
Thank you.